Welcome to our exploration of the free transformer. Since 2017, transformers like GPT have generated text autoregressively, one word at a time. This paper asks, what if they could make deeper decisions before generating text? Autoregressive generation produces text one token at a time, using only previously generated tokens. Decoder transformers work this way by predicting each next token from the past sequence. While powerful, this approach makes local token decisions without explicit planning of the overall structure. For example, a transformer trained on positive and negative movie reviews generates both well, but it decides sentiment implicitly. The first few words determine whether the review is positive or negative, rather than making that choice explicitly up front. Now let's see a mathematical example that reveals just how complicated autoregressive models become without explicit latent variables. Imagine we have a simple hidden coin flip, a binary variable z that's either 0 or 1. If we know z up front, the math is beautifully simple. Just a straightforward formula involving epsilon and z. But watch what happens when we express this purely autoregressively without access to z. The probability becomes a nightmarishly complex rational function with exponential terms and summations. What was simple with a latent variable becomes exponentially complex without it. The solution is to give the model more freedom by conditioning generation on learned latent variables. Rather than implicitly inferring high-level choices from early tokens, the model can make an explicit upfront decision, such as whether a review is positive or negative, before generating any text. It then produces content that stays consistent with that strategic choice throughout generation. Now let's formalize this idea mathematically. Any latent random value y_r can be expressed as a function of three things: the tokens generated so far, any previously sampled latent variables, and a fresh random value z_r from a random generator. This formulation is powerful because it means if we provide the model with enough independent random values during generation and train it properly, the model can build families of latent variables with arbitrarily complex dependency structures. Just like token selection depends on randomness, any activation influenced by a random value is a generation decision. This makes latent variables non-deterministic. Hidden decisions shape the output, unlike standard autoregressive models where everything is determined by the token sequence. The free transformer extends the standard decoder by using latent variables via a variational autoencoder. It learns hidden structure without supervision, adding little computational cost. Experiments with 1.5b and 8b parameter models show significant improvements, demonstrating that explicit latent decisions enable richer, more natural modeling efficiently.